Now that we know the rules of electron filling and knowing how many types of orbitals we have, we can make some labels on our periodic table to make sure that we know how this works. So get out your periodic table now, flip to the front of your notebook, and get ready to label it. Our periodic table is split into 4 main sections. So you have your metals over here, which is our S block. Our non-metals mostly over here, which is our P block. Our transition metals in the middle, which is our D block. And our metals at the bottom, our inner transition metals, which is our F block. Now, let's label our actual table. So, we start off with 1s, the lowest energy level. The s orbital has space for 2 electrons, and as you see, there are 2 elements, hydrogen and helium. Next, we go to 2s. So we have 1s1 here, 2s1, 2s2, and when we get to the right side, however, this becomes 2p. So we have 2p1, 2p2, 2p3, 2p4, 2p5, and 2p6. Let's continue this trend. 3s, 3p. Pretty straightforward, right? There's a little bit of a caveat, so just hold up. We get 4s. And here we'll go 4p in gallium. However, what do we do with this middle section? What do we do with that middle section? So at scandium, it's actually going to be 3d. Now, you might say, why does 3 come after 4? Well, remember, electrons will fill the lower energy levels first. It just so happens that our s orbital is lower energy, our 4s orbital is lower energy than our 3d orbital. That's important just to understand the order of filling. So let's continue to fill out our table. So we have 5s, 4d, we go across to indium, 5p. 6s, 5d, 6p, almost there, 7s, 6d, and at the bottom, which is kind of weird, is our 4f and 5f labels. That's because, again, these energy levels at the bottom, our F energy levels, are high energy. These elements at the bottom are really high energy. They have really high energy levels occupied in their electrons. And remember, again, for s orbitals, there's only 1 type, which means 2 electrons. For p orbitals, there is 3 types, which means 6 electrons. For d orbitals, we have 5 types, which is 10 electrons. And for f orbitals, we have 7 types for 14 electrons. Now that you've labeled your table, we can practice using it to write some electron configurations.